Assalamualaikum everyone. In this video, we're going to continue our lesson in chapter 2, number systems and code, with subtopic 2.3, numbering codes. We're going to look at two different numbering codes, binary coded decimal or BCD and gray code. Okay, first of all, numbering codes is a special types of coding where we convert numbers, letters or words into binary coding. Okay, so let's start with binary coded decimal or BCD code. Okay, in BCD codes, each digit of a decimal number is converted into its binary equivalent by using 4 bits only. Okay, for example, if I have number 1 in decimal, it will be represented as 0001 in BCD. If I have, let's say, number 10 in decimal, in previous subtopic, we learned that if we want to convert 10 in decimal into binary, we have to perform division, isn't it? And we have to divide it by 2, and then we get the remainder, and then that will become its binary numbers. But in this case, we're not going to do this. Instead, what we're going to do is we convert each of this digit into BCD or binary number on its own. Okay, for example, 0 is in binary is of course 000. Using 4 bits. Remember, we have to use 4 bits to represent each decimal number. And 1 is 0001. So this becomes the BCD code for 10. 10 in decimal number. Okay, let's look at the example shown here. This is another example. If I have a number 2196, it will, if we convert it into a BCD code, this is what it looks like. Okay, and if it's the other way around, if I want to convert a BCD code into its decimal equivalent, what I have to do is first I have to break the BCD into 4 bits groups, starting from the least significant bits is the right hand, the most the digit in the right side. Okay, and then I have to replace each bits into its equivalent decimal. So we reverse the process. Okay. Here, you can see some BCD codes for common number from 1 to 15. Common decimal number 1 to 15. Look at the number in binary form and also the BCD code. Look at the difference. The one in the red color here, you can see in binary, number 10, for example, we represent it 1010. But in BCD, as we did in the previous slide, is represented with 001, 0000. Okay, so that's the difference between binary number and BCD. BCD is not representing the value of decimal number. Instead, it is coding the decimal number into binary representation or binary code. Right? That's the main difference between the two. Okay, so let's have a bit of summary here between BCD and binary. So BCD is not a number system. Not a number system. It's a coding system actually. Okay, while binary is a number system, just like decimal, hexadecimal, and octal. Okay, in BCD, the decimal system with each digit encoded in its binary equivalent. That's just as I explained just now. Okay, and each decimal digit is converted into binary code individually using 4 bits. Okay, while binary is a straight binary code, it takes the complete decimal number and represents it in binary, where we have to perform division. We have to repeat division with 2 until we get the binary representation by using the remainder. Okay, the advantage of BCD code is that it is easier to convert, okay, from decimal digit into BCD code compared to if you're using binary, because we don't have to perform the division. Okay, and only 4-bit codes, 4 bits code group is needed to be remembered. Here is another example of how we can convert 137 to BCD, and then we compare how we convert 137 into binary number. Okay, so for BCD, we straight up look at the table and we can find what is the BCD code or binary code for number 1. Okay, number 3 is 0011. Number 7 is 0111. Okay, but for binary numbers, we have to perform division. Okay, just like we did in the previous subtopic, and then we get the remainder of the division, and that will be the binary number. Okay, what about if we want to convert a BCD code into decimal equivalent? To do this, we first break the BCD code into 4-bit groups, starting from the least significant bit on the right. Then we replace each 4-bit group to its equivalent decimal number, right? For example, if I have a code, BCD code 10000011, how do we convert this into decimal number? Okay, first of all, the first step is to divide the binary numbers into groups of 4 bits. Okay, here, the first group and 1 second. You need to start from the significant bit. Okay, and then we look at for example, this table. We look at this table 0011 3. Okay, so this one is 3, and 1000 is number 8. Okay, so this one is number 8. Actually, we don't need this table. Okay, we can just convert 0011 to decimal number by looking at its position 1013. So this one is 2 to the power of 1 plus 2 to the power of 0, which is 3. Okay, similarly with this one, 1000 is 2, power of 3 is 8. Okay, the most important thing that you need to remember when converting BCD to decimal number is that we're not going to convert the whole thing. Okay, we're going to convert it 4 bits by 4 bits. Okay, starting from the LSB. If we have like 16 or 20, 4 or what, no, doesn't matter how many bits lah, we can still convert it into decimal number by using this method. Okay. Okay, I want you to try this activity on your own. There are 2 questions there. First one, convert 863 in decimal number to BCD, and then convert the following BCD code into decimal number. Okay, try to do this on your own, and then we can discuss it in the next class. Okay.